Yeah, we're rolling. Okay. On your back, you had to answer some questions about how, like, what's it mean when you have, what does it mean? What's number one mean? Let me read it out loud, because when you solve a system, what does the solution XY mean? Yeah.
It's where the two lines intersect on a graph.
It's where the two lines intersect. So what happens when they don't intersect? What must that be?
They're either parallel or the same.
They're either parallel or they're the same line. The only way they could be the same line is if I disguise a line. Like if I have y equals x plus 2, and I want to make one that is the same line, all I do is multiply everything by something. Let's say 5. 5y, 5x, 10. It's the same line. When I give you a system where it's the same line, I never have y equals, because then you would know right away. If you solve this for y, what do you get? That. Okay, so systems are broken down into two kinds, yes.
Aren't you supposed to record?
Am I not recording?
You are.
I am.
Oh.
Systems are broken down into either called consistent or inconsistent. If they are parallel, they're called inconsistent. Tomorrow you will, well, you're going to get it today, but tomorrow you're going to get a homework assignment that gives you a system, and you just have to look at it. I don't want you to graph it. I don't want you to solve it. You just look at it and tell me, are they parallel? Now, how do you know? What is a system of two equations that make two parallel lines look like?
Kind of like an X.
Give me two. Give me one.
Did you say parallel lines?
Parallel lines.
You have them right there.
Two equations
Oh, they're the same.
that will produce parallel lines.
Y equals 5x plus 10. Y equals 5x plus 15.
What did he do?
And same
It's the
slope.
same thing.
He gave the same slope. Think about this. You have a coordinate plane. You have a y-intercept of 10 and a y-intercept of 15. They're climbing up 5 over 1, up 5 over 1, up 5 over 1. They're never going to run into each other. And when you're doing a story problem, I want you to think about things like that. Let's say you have somebody walking at 5 miles per hour in a race, but this guy started 10 miles from the start. This guy started 15 miles from the start. Is he ever going to catch up? No, there's no solution. They're never going to meet. Okay? Now, if there is a solution, there's two choices. There is either one solution, which is pretty much everything we've done so far, or there's infinite solutions, and this is only when they're the same stinking line. Okay? And that's the only way. I'll never have it as y equals on both of them, because then it's obvious they're the same line. I will try to disguise it, but if you solve for y, you'll always know if it's the same line. Obviously, every point works in both of them. Now, let's talk about one solution. When you're doing a story problem, let's say you have two copy machines. Copy machine A, copy machine B. This copy machine is making 50 copies a minute. And this copy machine is making 50 copies a minute, but when you went over to work with both of them, this one already had 3 copies made. Are they ever going to have the same amount of copies at the same time? No. What about if this one is going faster and it already had 3? Are they ever going? No, they're never going to. This one's faster and he's already ahead. Okay, think of a car. You're going 50 miles an hour. You're going 60 miles an hour and you started 3 miles ahead of them anyway. They're never going to catch each other. I just want you to start thinking about your story problems, and when you have equations, think about what they say when you get an answer. Now let's make this guy go slower. He's only going 40 miles an hour, even though he started 3 miles ahead. if you keep on going, will they ever catch up to each other? Yeah, this guy's going to eventually catch up because he's going faster. He has a higher slope. Question?
Unless he crashes, then he won't catch up.
Crashing is not in the story problem.
That's a possibility.
Oh my God. It is a possibility, but if it's not in the story problem, you can't make it up. You can't throw in, well, there was a crash, so there's no solution.
Could it be a variable?
You can't do it. There's no crash.
Okay.
When I say they're moving at the same rate, they're both moving, nobody crashed.
Where are they going?
Who cares where they're
Come on,
going?
We're going to Vegas.
Driving to Vegas is stupid. Okay, now, on your homework tomorrow, not today, you're going to have, today's homework is a practice quiz. I thought you could use it. Now, you don't have to do today's homework. You can just go on Blackboard and copy the answers, because I'm posting it. Am I gone?
Yeah.
Okay. You can copy the answers and I'll never know. I will check your homework tomorrow, and if it's all my work, it's all my work, and I'm never going to know. But I suggest you take the practice quiz, check your answers. You have to check them on your own. We do not have time to go over homework tomorrow. You're going to take a quiz, then you're going to do a homework over today's lesson. All right, let me show you another kind. Let's say, these are just called special systems, okay? Let's say you have y equals 2/3 x plus 5, and you have y equals negative 3/2 x plus 5. How many solutions are there? It's the same line?
I think so. Because one's going down and one's going up.
How could it be the same line then?
Because they have the same y, they have the same starting point.
If one's going down and the other one's going up, how could it be the exact same line? Okay? Can't be, right? All right? So it's definitely not parallel.
One solution?
Do we have, there's one solution. It's different slope, right? One's going up, one's going down. Now, this is a special case.
Consistent?
It's a special case because these two cross at a 90-degree angle. They're perpendicular. I'm going to give you one more example of a perpendicular system and see if you can tell me how you can create one. Y equals 5x minus 3. Y equals negative 1/5 x plus 6. That's perpendicular. I know it is. If I graph that, they will cross at a 90-degree angle. What did I do?
You made the slope, like you did the reciprocal and you made it negative.
The negative reciprocal of the slope will produce perpendicular lines. Yeah.
The reciprocal of 5, negative 5.
The reciprocal of a
Oh,
fraction
one, yeah.
is when you flip it upside down. It's what times 5 equals 1.
Okay.
5 times 1/5 is 1. The reciprocal is the fraction that when you multiply it, you get 1, always. And you have to make it the opposite. It doesn't make sense if they're both going uphill. They're going to cross, one's up, one's down, at a 90-degree angle. All right? Now I'm going to write an equation, and you give me an equation. Now there's an infinite amount of choices. That is perpendicular to that one. Matt Southern. I figured since you weren't listening, I would wake you up.
Sorry, I didn't get much sleep last night. Are you eating?
Lack of sleep. Yeah.
Negative 1/3.
No.
Positive 1/3?
That's it? Just positive 1/3?
X.
X. Can I have a plus anything?
Yeah.
Yeah, it doesn't matter where it crosses. I could have plus whatever. Or I could have plus nothing. They could cross at 0, 0. But opposite reciprocal. Okay? Now I'm going to give you an equation. Give me an equation that is parallel to that one. It's an infinite amount of choices. Parallel. Read?
Negative 1/5 x.
Nope. You know why I know right away it can't be parallel? Because we got one going uphill, one going downhill. How could they run side by side?
This one's negative.
You're thinking of perpendicular. I just said parallel. I switched words on you. Jordan,
Y equals 5x plus 6.
5x plus 6. 5x plus anything. 5x minus anything. Why are they parallel? Because they're climbing at the same rate. You with me? Okay. All your definitions are on there. On the homework, not all of them are solved for y. Solve for y first, because you can't compare slopes if you don't solve for y first. Now, you might be able to tell if something is infinite solutions just by looking at it. Like, look, x minus y equals 2, 6x minus 6y equals 12. You might not have to solve for y to see. All she did was multiply everything by 6. Infinite solutions, because it's the same line. Okay? I'm not going to require you to solve for y on that one if you can tell that it's the same line. And then there will be 2-story problems. And that's pretty much it. You can do these with elimination and substitution. Remember yesterday when they were equal to each other, it was infinite solutions. When one was not equal to each other, no solution. Okay? All right. You can go ahead and turn that off. I want you to do the practice